We're going to wrap up chapter 5 here with what's called indirect measurement. And indirect measurement uses similar shapes to calculate measurements that are difficult to measure directly. So when you measure something directly, that's like putting a ruler on it or putting a tape measure on it and actually measuring how long something is. And sometimes it's difficult or not even possible to put a ruler or a tape measure on something because we don't have tape measures that long, or the objects that we're trying to measure are inaccessible or hard to get to. So we can use similar shapes that we just talked about to help calculate how long something is or the measurement on something rather than measure it directly. So an example that I have here, I have a statue of at a World War II monument and then a person, and they're both casting a shadow. Well, these heights and shadows actually form similar triangles. So the heights and the shadows form similar triangles, and we can use those triangles to calculate the height of the shadow. So I can use the length of the shadow, which I can measure, and I can use the height of the person, which I can measure, and the height or the length of the person's shadow to calculate how tall the statue is, since I can't get to the top of the statue. So what I did was I used these similar triangles to set up a proportion, just like we did in our last lesson. So here is the proportion I set up. The height compared to their shadow. So height to shadow is equal to height to shadow. Those two ratios are going to be equal to one another. So then if I solve this proportion, I can calculate the height of the statue. And there is a nice vertical relationship here that the object is twice as long as its shadow. Okay, the person is twice as long as its shadow. That means the statue also has to be twice as tall as its shadow because these form similar shapes. So all I have to do to calculate the height of the statue is take its shadow times 2. And 43.5 times 2 is 87. So the statue is 87 inches tall. Okay, and that's basically indirect measurement, creating similar shapes to solve or to measure something indirectly. So suppose a bell tower casts a 27.6 foot shadow at the same time a nearby tourist casts a 1.2 foot shadow. If the tourist is 6 feet tall, how tall is the tower? Now, again, whenever it comes to geometry problems or measurement problems, I have to visualize it. I need to see it. So if you just make a sketch of the scenario and label all of the appropriate parts, then we can see the corresponding parts and we don't mix up our numbers at all. So I'm just going to make a real quick sketch here. Pardon my artistic abilities. So here's my bell tower, and it's casting a shadow. So there's the tower and its shadow. And then I also have a tourist. Hey, what's up? And they're casting a shadow too. So it doesn't have to be an elaborate drawing, just enough to visualize the parts. Now I go back through the problem here, and the bell tower is casting a 27.6 foot shadow. So I'm going to label that. The shadow is 27.6 feet. The tourist is casting a 1.2 foot shadow, and the tourist is 6 feet tall. How tall is the tower? So we have some missing parts here. So here is our triangle, and it's going to be similar to this triangle. So these are right triangles, and I don't know the height of the tower, so that's the missing part. So I can create a proportion to help solve this problem. So I'm going to go shadow to shadow, so the small person's shadow to the bell tower shadow, since these are corresponding parts. These are both the bases of the triangles. That's going to be equivalent to the height of the tourist to the height of the tower. So I've gone shadow to shadow ratio is going to be equal to height ratio. So here's my proportion. Now I've got all these ways to solve it. If you go ahead and use the cross products, or maybe you used a horizontal relationship, there actually is a really nice horizontal relationship here. 1.2 times 5 is 6. So I'm going to take 27.6 times 5 to get x, and that gives me 138. So the bell tower is 138 feet tall. And again, that would have been quite difficult to measure directly. You'd have to climb all the way up there and have something long enough to measure that. But we used similar shapes and geometry to measure the bell tower indirectly. Here we can find distances on the ground as well. These are called surveying techniques. So a surveyor is a person that takes measurements of land and things like that. A surveyor places stakes in the ground at S, T, and U. So here they put stakes in the ground to create a triangle. And then they created these similar triangles, STU and VQU. And then she measured the lengths of ST and TU because those are on the ground and those are accessible. What she's trying to do is figure out how wide this pond is, and it's difficult to measure that directly. So she created these similar shapes here to help her out. We need to use these similar triangles to find the width of the pond, X. So again, I'm going to use my corresponding sides here. Now this side and this side are actually corresponding sides, so I'm going to write their ratio. 10 meters to 16 meters is equivalent to, and then the 20 and the X are corresponding sides, 20 meters to X meters. So then here obviously we've got a very nice horizontal relationship. That's times 2. So 16 times 2 is 32. So our pond is 32 meters wide. So again, using similar shapes to help us find missing measurements. Here again, we've got a distance that we're trying to find, and the figure triangle QRS is similar to URT. So again, we've created some kind of flip-flopped similar triangles here. Find the distance from the cabin to the mess hall. So cabin to the mess hall is what we're looking for here, and it corresponds with this side right here on the triangle. So I'm going to go ahead and write that ratio first. The missing side is to 60, as this side is to this side. So this is the smaller measurement. It needs to go on the bottom, and the larger triangle needs to go on the top. So here we have this measurement, and again, you can use any method you want to solve this. I don't off the top of my head, times 3. There we go. 46 times 3 is 138. So to find the distance from the mess hall to the cabin, I'm going to take 60 times 3, which is 180 yards. So using those similar shapes to find missing measurements. So again, we're just applying similar shapes. We're applying proportions to use what we call indirect measurement to find measurements that we can't access easily.